Okay? And sometimes I wonder how many times I say okay. When I edit myself in video, I'm like, Jesus Lord, I probably say that 26 times. Okay? All right, well, let's look at some basic properties that I sometimes forget to point out. And that is, we know that's 1 because the understood base 10 needs an exponent of 1 to equal itself. Same thing, that. So if you have the base and the value the same, it's always 1 because we need a 1 exponent to the base 2 to equal itself. And the same thing with this. Right? Because again, understood base E needs an exponent of 1 to equal itself. All right, so the general rule, the log, the base of the base equals 1. All right, and then there's another thing that's really interesting, which I'll get to in a second. And that is, how can we use logarithms to solve this problem? We certainly can't use the bases are the same on both sides right now because there's no way we could get 3 to become a 2 very easily. If 3 was 4, no problem. If 3 was 8, no problem. If 3 was 16, if 3 was some power of 2, then we could solve this. But right now, that's not possible. All right, so let's think about how we could do this. Well, maybe you already know. But I'm going to point out something. If we change the 2 and the 3 to the same base, then we could solve this problem. Okay, so let's say we're using base 10, which is common, or base E would be okay too, but let's just go ahead and use base 10. Well, if I want to change 2 to base 10, I need the log of 2. That'll be the exponent to base 10 that equals 2. So this now is 2. That's what a log is. It's the exponent you need to the base to equal the value. We want to equal 2. The log of 2 will get us the exponent to base 10. All right, so now we know that is 2, so that's x. Let's do the same thing with 3. Let's change 3 to base 10. Okay, so base 10, the exponent we need is log 3. Okay, so that's what this log means. That means this is the exponent to base 10 that will equal 3. So that's 3. So we've transformed this problem by using logarithms based on 10. Now the bases are the same on both sides, and so now we solve this problem. And now we can do that. We can do this in our calculator. That's what logarithms are useful for, because it would be difficult any other way to solve that. Okay, so doing what we just did right here basically means this will produce a 2 when you apply the log 2 exponent to 10. This will produce a 3 when you apply the log 3 exponent to 10. Okay, well, what if you had 10 log 10? Well, that equals 10. Okay, so another property that's very useful. If you apply the log of the base to the base, that equals the base. So that is very useful. All right, so let's see. Okay, not quite yet. All right, so let's go ahead and look at some properties. So here we solved this equation without using any properties, just kind of thinking about how we could change the problem so that they have the same base, and we use logarithms for the exponents such that we will have the value equal to 2 and the value equal to 3. So they just transform the equation so we could solve it putting the exponents equal to each other. Right? But this is an actual property.